Hello everybody, Don KK4QAM here. It's been a while since I posted a video. I thought I'd give you a little quick update. A while back I started a new project here for the home QTH. It's an autonomous satellite tracker. It's an Arduino controlled satellite tracker with azimuth and elevation. It will also create its own web page so that you can connect to the web page. Select your satellite, it will download the Kelperian data, and then you hit track. And it will engage the azimuth and elevation servos to have a continuous sweep on that satellite. I hope you enjoy it. Stick around.
Okay, let's try something different.
In this video, we'll be going over the servos and a mod that I had to do to one of those, as well as my 3D printed control box and servo mounts for the autonomous satellite tracker. Stick around. By the potentiometer feedback on the elevation servo and following the instructions from Servo City, where I got the servos at. Once I got in there, I found that this one right here, this yellow wire, was actually, the cover was put down on it and it was pinched, so I actually had to make a repair here. But basically I had to desolder the green, the yellow, and the red wire and provide a way for them to come outside of the servo to connect to an external pot. Then once you desolder these and create your basically a hole for those to come out of, you put this board back in and put everything back together. Here they are coming out of the servo right below the power, negative, and pulse width modulation cables. Here it is in the frame that came from Servo City on the servo tilt assembly. And they do look short, but once I bend the prongs to the servo down, I can make the soldered connections there as well and put some type of a rubberized paint on them to help keep some moisture and environment out of them. Here's the servo mounted in the tilt assembly before I put the pot in. You can see the small gear here with the bearing for the pot to come through, and the pot's actually mounted on this side, and the wiring connection is on that side as well. Here are both servos in their assemblies, mounting or what have you, the two gears that give you your gear ratio, and I think this was a 50-to-1 gear ratio based on the teeth. They're very good high torque servos, and this is a very nice kit. In order to mount everything, I got to thinking, you know, I don't want to have a permanent mount, and the servos are not weather tight. I wanted to make it to where it would be sort of portable. So I have some of the fiberglass military mast, and I 3D printed this up to slide over the end of one of them. The slots here are for a hose clamp to go around and pinch down on it. This is a 1/4-20 threaded hole that you could use to mount it on, and the control box is actually made to mount on this with the 1/4-20. I went with the 1/4-20 because you can use a tripod as well as something like I'm designing to mount it on for a more portable use. There's a bottom side photograph of it, just showing you how the slots is cut in it. And here it is mounted on the top end of a military mast with the bolt attached and coming out. Here I have my control box printed out. I have the 1-buck converter put in, the ESP8266, along with the servo control board as well as the GPS board. This is the 1/4-20 hole for mounting it to my post mount or mast mount or a tripod. Here I'm starting the wiring with some of the little cables that I bought. You know, you have to kind of pay particular attention to them. I know Ham Radio Concepts, Eric, said that he had trouble with some of these cables and he wound up having to hard solder everything together. But if you notice, my boards are not laying flat, and that's because of one particular reason. Earlier on, you seen that when they was brand new, they did not have the header pins soldered in. I soldered all the header pins in so that I could connect and test run everything, or at least make sure the electronic side of it was working correctly on the little test boards I have. And so in order not to have to make everything control box wise so tall for board clearance as well as the length of these cables plus a bend, I got to thinking, I said, well, after rereading the article, there's only one board that says it has to be mounted in a specific orientation, and that's on the boom. So I designed this control box for putting everything on the sides with these little arms here that has the indentation that wraps around them so they can just basically slide into it. I have a hole over here for the elevation servo, which is these yellow, red, and black wires coming out here. These 3 wires here wrap around and come out the other side of the servo control board, and those will be going to the spatial sensor, which is mounted on the boom. This hole here will be for a on-off switch. This square hole here will be for my power pole mounts, and this round hole at the bottom will be for my external GPS antenna connection. And in case you're wondering how small some of them are, this is one of the buck converters that I have already preset up, because you can see the solder here where I was feeding in the power and measuring them on the output side here. There's the adjustment pot. Now these, they turned out to be very, very good buck converters because I had a meter measuring the input as well as a meter measuring the output. Once I had the output set at like 13.8 off a typical power supply, I would run the voltage up and down, and the output side never changed except for maybe 1 decimal point. Here I have the power pole adapter stuck in the hole, the switch mounted. Got the tape holding my ESP8266 down because it's wanting to slide up as I'm hooking power to one of the buck converters. Now everything is installed and wired up, and as you can see, I broke off one of my little supports on the ESP8266, so I put a dab of hot glue on it. It didn't turn out to be as nice and pretty as I wanted to, but when I turned it on, the magic smoke stayed in. Here you see another cable coming out, and that's for the Azimuth servo. So I have both servos connected, but the elevation goes through this hole, and the Azimuth actually comes through the top. All right, here is a pre-wiring assembly of everything, and as you can see, here's the control box with the hole for the elevation servo coming out. Here is the Azimuth servo, and these holes are functional and do line up, but the bolts kept hitting these, so I just omitted them. What I did was I took the whole Azimuth assembly and I integrated it into the top of the box so that it would all be somewhat modular and in line with each other on top of the mast. This gear on the Azimuth, I made the base for the elevation. There you can see a nut and a bolt coming through here. There's 3 or 4 of them around there. This is just smaller than the outside diameter of the teeth on this gear here, as well as coming back here and bolting into the back and some on the other sides. And if you notice, this tapers off because I missed my measurements here by just a little, but it actually turned out to be better in the long one because it gives me clearance off of this small gear here. Here's a front side view, pot, the gear, shaft going all the way through to the pot and the elevation platform. Another nut, one here and one there, and I think there's one in the back there, with the base just shy of the teeth on this gear for the Azimuth servo here. Here is the cables from the Azimuth servo coming through a hole in the front, and as previous stated, there's where I will put my switch and my power poles. It's a side view of it. It's probably not the best print job in the world, but I did design and lay out everything that I 3D printed for my control box and top with the integrated Azimuth controller, as well as the elevation mount onto the wheel. So it took a little time to do, but it turned out to suit my needs. One thing to remember is these servos, the servos themselves, are not weather tight, and you will need to take these in once you're through working satellites to keep the elements and the weather from getting to them. Thanks for watching. I hope you enjoyed it. Look for more videos as they come out in the series of the build of the autonomous satellite tracker 7.3.